We have pondered our place amongst the stars since the dawn of humankind. We've looked at the stars with wonder and amazement, their glow guiding our travel for centuries. The more we learn about our universe, the more questions we have. Today, we'll explore where NASA and its partners are taking us in the future. But before we begin this journey, just like every NASA mission, our number one goal is to return home safely. So always stay seated while the bus is in motion. Please, no food or drinks on the bus with the exception of water. Please keep conversation to a minimum so others may hear and enjoy the tour. No photography is permitted at the security gates, but there will be plenty of photo opportunities during the tour.
This rocket that you'll see standing tall in front of KSC's badging station is the Mercury Redstone rocket. It represents NASA's earliest efforts to send humans into space. These Redstone rockets were formerly ballistic missiles provided to NASA by the U.S. Army. In October of 1958, NASA formally organized Project Mercury with a mission to investigate man's reaction to this new environment and safely recover the capsule and its pilot. Man rating for human spaceflight on what was previously a ballistic missile was no easy task. After several modifications and test flights, a Mercury capsule carrying Ham, a chimpanzee, was successfully launched and recovered on January 31st, 1961. Just months later, on May 5th, astronaut Alan Shepard launched on a Mercury Redstone rocket, becoming the first American in space. I'm Emily Calandrelli, and today you'll be following me behind the gates on this exclusive bus tour of Kennedy Space Center. Our journey will take us past active facilities, launch pads, and end at the visitor complex's own Apollo Saturn V Center. But first, here to welcome you is Janet Petro.
Hi, I'm Janet Petro, and welcome to NASA's John F. Kennedy Space Center, where NASA astronauts have ventured forth on flights of exploration since the 1960s. And what an exciting time to visit our multi-user spaceport in our ultimate mission, the Artemis program, where NASA will return to the moon and continue on to Mars. In all our history, there's been one common theme woven throughout our DNA. It's our insatiable desire to explore beyond our home planet in our never-ending quest to expand our knowledge of the universe. As you venture behind the gates, you'll find a community of the most talented, dedicated, motivated workforce anywhere in the world who believe in the unlimited potential of space exploration. This is an active spaceport where new things are happening every day. You never know what you might see, so enjoy your tour.
If you're curious what the new building on the left is going to be, that is called the Giga Bay for SpaceX and the Starship program.
140,000 acres, NASA only occupies about 7,000 acres. I want to introduce you to Becky Bolt, who has been a NASA wildlife ecologist here at KSC for nearly 35 years. Becky, what kind of wildlife can we expect to see here today?
We have lots and lots of different kinds of wildlife. We have over 400 species that occur out here on the Space Center. What you are going to see is going to depend on what the weather is, where you are, what kind of habitat you're driving through. Look in the ditches and you'll see lots of wading birds, tall herons, egrets, ibises. There's several species of those, and I can pretty much guarantee you're going to see some of those. We have bobcats, raccoons, all kinds of animals.
Now, what is your role as a wildlife ecologist?
One of the main things we do is support operations. So people always think, oh, that's launch. Well, Kennedy Space Center is big and we have a lot of employees. It's like a city. We have lots of roads, we have lots of buildings. And so there's lots of maintenance and construction and taking buildings down that are old, that aren't used anymore. So anything that might impact the habitat or wildlife, we have to go out and we check it out. And we work with the project managers to make sure that animals aren't harmed or things need to be, like gopher tortoises are notorious for this. They go places where they shouldn't be and sometimes we have to move them. We also support launches. We do a lot of research because we help the land managers, which on Kennedy Space Center, the land managers are the Fish and Wildlife Service because this is a wildlife refuge. We provide them data to know how to manage their habitats. We have federally listed scrub jays and federally listed beach mice. There's probably some watching us right now. And so we provide that data to them so they know how to manage the land in the best way.
Well, Becky, thank you so much for teaching us how nature meets technology here at KSC, and hopefully our guests on our tour will see some of this wildlife today.
You are now approaching the Vehicle Assembly Building, or as NASA calls it, the VAB. It is one of the largest buildings in the world by volume, and is the place where NASA completes the final assembly of its rockets before launch. The sheer scale of this building is hard to grasp, even when you're right next to it.
Do you ever feel really small when you think about space? What about when you're standing next to a skyscraper or a really big bridge? Well, I feel about as small as an ant right now. I'm standing inside the Vehicle Assembly Building trying to grasp how large it really is in here. It has 4 bays. Each bay has 2 large horizontal doors below it and 7 smaller vertically opening doors above it, tall enough to fit the world's largest rocket through. In fact, these are the largest doors in the world.
Construction of the VAB required 65,000 cubic yards of concrete, 45,000 steel beams, 1 million steel bolts, amounting to almost 100,000 tons of steel. Notice the flag painted on the outside of the VAB? It's the size of a 21-story building. The blue section alone is the size of an NBA basketball court. Each star is 6 feet across, and each red and white stripe is wide enough for this bus to drive down. And the entire VAB? It's so huge that the Roman Colosseum would fit on the roof with room to spare for a parking lot. By volume, the VAB can fit 3.5 Empire State Buildings, and it would take 250 billion ping pong balls to fill it. It was built in the 1960s for the Apollo program. Every Saturn V rocket that sent humans to the moon was assembled right here. Every space shuttle mission also assembled within these same walls. After the space shuttle program, a major renovation to the inside of this building began to accommodate NASA's next generation of rockets, the Space Launch System, or SLS. Since 2010, NASA's Commercial Crew Program has worked with American aerospace companies to create cost-effective access to the International Space Station, known as the ISS, and other low Earth orbit missions. Launching from right here at Kennedy Space Center, astronauts can now travel to the ISS aboard spacecraft developed by private companies SpaceX and Boeing. Since the successful launch of Demonstration Mission 2, also known as Demo 2 in 2020, SpaceX has regularly sent crews to the ISS via Crew Dragon. Launching atop SpaceX's Falcon 9 rocket, the Crew Dragon capsule can carry up to 7 astronauts and with cargo seats 4. Upon returning to Earth, Crew Dragon splashes down in specific locations in the ocean based on criteria such as weather and the spacecraft's position in orbit. In 2015, Boeing opened its Commercial Crew and Cargo Processing Facility in what was formerly the Orbiter Processing Facility for the Space Shuttle program. You can see this building next to the Vehicle Assembly Building, boasting a large, colorful mural of the CST-100 Starliner spacecraft in orbit. Starliner can seat up to 7 astronauts, 4 with cargo, and launches atop the Atlas V rocket made by the United Launch Alliance, or ULA. Upon its return to Earth, rather than splashing down in the ocean, Starliner deploys airbags to land in the desert of the western United States. Starliner was the first American-made human-rated capsule to land on land. Since 2012, NASA has contracted private companies through commercial resupply services contracts to deliver supplies and research to the ISS using commercial spacecraft. These companies launched from Kennedy Space Center to the ISS to deliver cargo and return research samples and unneeded cargo from the space station back to NASA on Earth. This public-private partnership allows NASA to maximize the use of this one-of-a-kind laboratory to advance scientific knowledge and better understand our planet.
Control 9, Alicia BC.
As we follow the crawler way on your left from the vehicle assembly building to the launch pads 39A and 39B, we enter an area of action, tracing the path of astronauts and the rockets that carried them to the Moon and International Space Station. Here, surrounded by nature, NASA and its partners push the limits of technology and imagination to grow our understanding of the universe. Each new mission gives us new knowledge to help us protect our planet and the lives on it. Soon, we'll be arriving at the gantry at LC-39, where you can learn about ways NASA is using information gathered from space and get an up-close look at launch pads 39A and 39B. From the observation tower, you can also see Space Launch Complexes 40, 41, and 37 on Cape Canaveral to the southeast, as well as a 360-degree view of Merritt Island National Wildlife Refuge. Keep a keen eye on the Banana River between the tower and Cape Canaveral. You might even see a dolphin or two. With new launches and heightened goals always around the corner, this is an area of constant activity.
Do not forget to tell them about today's static test fire. We are finishing final preparations now.
Oh yes, everyone, meet Sol, our artificial intelligence assistant assigned to the gantry at LC-39. She's helping some of NASA's engineers with a new prototype engine stationed in the observation tower. In a short while, they will be testing the engine's full thrust capabilities to see if it meets NASA's criteria for deep space exploration. So, what do our guests need to know?
This is a really exciting opportunity and perfectly safe. You can go underneath the engine and feel the effects and power of the test fire yourself. You will find the results to be quite extraordinary.
Thanks, Sol. We'll see you at the gantry. Good luck. Before exiting the bus, please check around your seat to make sure you have all of your belongings and carry them with you. When you're done exploring, return to the bus pickup area and a crew member will direct you to the next available bus. Welcome to the gantry at LC-39.
Alright, if you notice a giant TV on the side of the gantry, that giant TV will eventually show a countdown clock. That countdown clock will let you know when the next static test fire is, and they happen roughly every 30 minutes. Make sure you guys gather all your personal belongings, this way nothing gets left behind. Please watch your head as you go to stand up. Hitting your head on a TV or storage compartment truly does hurt. And watch your step as you're getting off the buses that may be higher or lower than you would expect.
All right, good afternoon, everybody. My name's Carmine. For the next part of our mission, we are heading up to the Apollo Saturn V Center, where you can look at a real Saturn V moon rocket. You're going to learn a little bit more about the early moon missions, and you'll have the chance to touch an actual moon rock.
NASA is known for dreaming big, and big dreams require big equipment. I'm standing next to the Crawler Transport, the largest self-powered land vehicle in the world. It was originally built in 1965 for the Apollo program, and has since been updated to accommodate the space shuttle and now NASA's SLS rocket. Weighing in at 6 million pounds and capable of lifting and hauling 18 million pounds, the Crawler is an engineering marvel, even without a rocket sitting on top of it. This thing has 2,750 horsepower V16 diesel engines that can carry the crawler up to a top speed of, wait for it, 1 mile per hour while carrying a rocket. Keep an eye out for the crawler as we approach this area. And remember, we are visiting a working spaceport, so while the crawler may not stay in one area for very long, it's bound to be out here somewhere. Now, let me introduce you to my friend, John Giles, the Crawler Project Manager.
I'm standing in front of Crawler Transporter number 2 at Kennedy Space Center. Crawler Transporter 2 is used for the SLS program to take the launch vehicle back and forth to the pad. To move the rocket from the Vehicle Assembly Building, or the VAB as we call it, to the launch pad, a certified operator carefully maneuvers the crawler underneath the mobile launcher where the SLS is stacked. We then pick up the mobile launcher and the SLS rocket together and slowly, very slowly, carry it to the launch pad. It's a 4.2-mile trip that takes 7 to 8 hours. We'll roll over a specifically prepared crawler weight that consists of river rock, anywhere from 8 to 12 inches thick. Below that is limestone that's 4 to 5 feet thick that is hydraulically compressed. And then below that is another 20 to 30 feet of sand which supports the weight of the crawler and the mobile launcher as we roll over top of it. Once we're at the launch pad, we drop off the mobile launcher and the SLS rocket. And after the launch, we come back, pick up the mobile launcher with the crawler again, and bring it back to the VAB. Then we'll repeat this process for the next Artemis mission.
With 50 years and some 3,000 kilometers or 2,000 miles on the clock, NASA expects the crawlers to be in operation for at least another 3 decades. How cool is that? The crawler will be doing what it was originally designed to do once again, which is moving rockets.
Artemis's launch commentator. Take a look at the 4-story building that you see right now. That one with the slanted windows, that building is the Launch Control Center, or LCC, where launch directors and their teams oversee every NASA rocket that lifts off from the Kennedy Space Center, and it's where they give the final go or no-go for launch. We're inside the LCC now with Charlie Blackwell Thompson, NASA's first female launch director. So Charlie, tell me what your role is as launch director, and then what happens inside this room?
The launch director is responsible for working with the team on the launch commit criteria, the rules with which we are go, no-go. There's a lot that we have to do to be ready for launch.
So what's it like on launch day for you and the 100 engineers that you have watching the systems of the rocket before liftoff?
On launch day, this room is the hub of excitement because the team is focused, and the closer you get to T0, the quieter it gets. You can almost feel the concentration in the room.
Now, this room, of course, is very interesting. You can see from the outside that the windows are very large and they're slanted. It has an operational purpose, but it does provide quite a view of the wildlife out there.
It certainly does. But the windows are like this by design. And as you can see, as you look out the windows, what a great view you have of Launch Complex 39A and 39B. And so during the Artemis launches, we can look out to 39B where we launch from, and you can see from the core stage engine start to booster ignition through the ascent trajectory until the vehicle is well overhead.
So where were you when you were watching Artemis 1 launch back in November of 2022?
So for the launch of Artemis 1, I was here in Fire Room 1 at the launch director console.
We've talked a lot about the Artemis campaign. We've mentioned it several times. What is the Artemis campaign about?
So the Artemis campaign is returning us to lunar exploration for the first time since the Apollo program ended in 1972. The beauty of what we're doing is that we're not going for a short stay. we're going to have a sustained presence on the moon. When we can learn to live away from our home planet, and we can take those lessons that we learn and apply them to deep space exploration.
Okay, excuse the interruption. I want to point out we're approaching the crawler transporter parking area, so if you want to get your cameras or cell phones out, I will point it out. If you look to your right, you see that little white building with the green pipes hanging out. Right behind there, you're going to see crawler transporter number 1 coming into view here momentarily. There she is right there. And if you look off into the distance just past this building, you'll see the 2 mobile launch pads we have. And there's crawler transporter number 2 about to go under one of those mobile launch pads right there. And as a bonus, sometimes we get lucky. Up here on your right, we call this our gator hole. We might see some alligators, we might not, we'll see.
For a journey to Mars.
The way we're getting to the moon, of course, is with the help of a very powerful rocket, the Space Launch System, or SLS. Tell me about this rocket's capability.
This rocket is key to us returning to the surface of the moon. It is about 15% more powerful than the Saturn V vehicles that we used for lunar exploration prior, and it weighs about 1 million pounds less.
What else about the Artemis campaign do you get excited about?
I think about the Artemis generation and the curiosity and the inspiration that these sets of missions will ignite in that generation. There's also scientific discovery. We're still learning from the samples that we collected during the first trip to the moon, the first trips to the moon. And so what are we going to learn when we're there to stay? And then, of course, there's technology development. If you think about some of the things that apply in our daily lives, flame retardant materials, miniaturized electronics, and how they have made such an impact in our daily lives, and all of those, you can find a thread back to NASA exploration.
Well, thank you, Charlie, for telling us about your role and showing us what happens inside this room. It was really exciting to listen to you talk, and thank you for being here.
Oh, it's my pleasure to be here. I love talking about the launch team and what happens in the Launch Control Center. And I hope all of you have an incredible day. Enjoy your day at Kennedy Space Center, and go Artemis.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why 35 years ago fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
When President John F. Kennedy made this speech in 1962, he set in motion an era of discovery that would change humankind forever. 7 years after he spoke these ambitious first people to walk on the moon. The achievement of the men and women who worked on the space program in these early decades of NASA helped propel the technology we use every day. NASA and the thriving private space industry at Kennedy Space Center today are the living legacy of their story. As we arrive at the Apollo Saturn V Center to learn more about that historic era, get ready to step back into a time when NASA had everything to prove to a nation focused on one goal: to be the first country to land a person on the moon.
Please check around your seat to make sure you have all of your belongings before departing the bus. Wait at the metal doors to enter the Apollo Saturn V Center. A new show will begin every 10 minutes. Stay and explore as long as you like, and simply exit through the Right Stuff gift shop to board a bus back to the visitor complex. About a 15-minute ride with buses departing frequently.
right, good afternoon, everybody. My name is Carmine. For the last leg of our mission today, we are heading back to the visitor complex where this tour first began. It would usually be about a 15-minute ride. Today it's going to be a little extended because we have construction going on. We have to take a little detour. But on the plus side of the detour, we get to drive right by Blue Origin and spy on Jeff Bezos and see what they're doing over there. When we get back to the visitor complex, I'll be dropping everyone off at the Atlantis Space Shuttle exhibit. So if you haven't checked it out yet, please do. And here we go.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach, pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions.
I'm Christina Cook. I'm a mission specialist.
I'm Jeremy Hansen. I'm a mission specialist. I'm Victor Glover. I'm the pilot.
I'm Reed Wiseman. I'm the commander for the Artemis II mission to the moon.
To the moon.
To the moon.
To the moon.
When I was young, I had a poster of the Earthrise picture, the famous picture that was taken on Apollo 8. And the fact that it was a human behind the lens that made that picture so profound and changed how we all thought of our own home was so amazing to me. The moon is not just a symbol of thinking about our place in the universe. It's not just a symbol of exploration. It's actually a beacon for science. It's a beacon for understanding where we came from.
You know, pushing ourselves to explore is just core to who we are. It's a part of being a human. That's our nature. We go out there and we explore to learn about where we are, why we are, understanding the big questions about our place in the universe. The exploration we're doing is the first few steps on the path of getting humans to Mars.
The Artemis campaign and missions have set such an ambitious goal for humanity that's inspiring contributions from around the globe. Not just one nation is inspired and moved by this, but nations from around the globe are coming together. When I look at the Artemis 2 crew with Victor, Christina, and Jeremy, they want to go do this mission. They are keenly driven. They are humble to a fault. It is.
Alright, please excuse the interruption. The very next video we're going to watch, ladies and gentlemen, is going to talk about our eagle's nest that we have here on property. We are coming upon the eagle's nest in another mile, so I want to give you a chance to get your cameras or your cell phones out if you want to take a picture of it. It will be on the right-hand side of the door side of the bus in the tallest pine tree you're going to see on the right side. Momentarily will be our eagle's nest. It'll be on the top in the center. They make them, the old nest is pretty much like the new nest, about the size of a king-size bed, so it's hard to miss, but if you don't know where to look, it's easy to miss. So I'm going to start slowing down. People in the front, you can probably start seeing it, that tallest pine tree in the distance there. There is our eagle's nest. I'm going to go down another 5 miles an hour. Get your cameras ready, start looking up into the trees. There is our eagle's nest, ladies and gentlemen, and the very next video is going to talk all about it.
So cool to be around them. Artemis 2 is a huge mission, but I hope we will look back and realize that this was one tiny step in humans on Mars and a sustained presence on Earth. Artemis 2 will be NASA's first crewed flight test of the Space Launch System rocket and Orion spacecraft around the moon.
To verify today's capabilities for humans to explore deep space
And pave the way for NASA's long-term human and scientific presence on the lunar surface.
we are ready.
We are going to the moon for all humanity. We are Artemis.
Eagles have long been a symbol at NASA for human spaceflight, including the famous Apollo 11 mission. So it seems only appropriate that so many call Kennedy Space Center home. They arrive in late August, hatch their eaglets around December, and stay until spring when they migrate back north. For over 20 years, breeding eagle couples return to the same nest along Kennedy Parkway, spawning multiple generations of eaglets. This nest weighed thousands of pounds and measured roughly the size of a king bed. But over time, the tree containing the nest was damaged by natural forces. Wildfires, hurricanes, and even a pine bark beetle attack. And a storm in 2021 destroyed part of the original nest, making it uninhabitable. NASA wondered what was to become of its resident eagle. But they returned and built a new nest even closer to the road. Look high up in the tops of the trees to your right, and you might be able to see it.
We're here in front of Space Shuttle Atlantis, which played a key role in the assembly of the International Space Station, or ISS. I'm here with Bill Dowdell, who's the technical director of the ISS.
Hi, Emily.
Hi, Bill, can you tell us what is the purpose of the space station?
The space station was built to conduct research. We're in a partnership with Russia, Canada, Japan, and Europe, and we're working with companies from all over the planet to be able to do that science and technology development up there. We're working with many companies here in the United States to continue that process and to come up with new technologies that will benefit us here on Earth.
Right, and I know there's a lot of research that goes on up there. What are the benefits of that research?
Well, almost everything that we do on the ISS has a derivative here on Earth that benefits humankind. Every time you pull out your cell phone to take a picture, the sensor in that cell phone that you're using to take that picture with was developed by NASA. We're doing medical research on Earth for crew health that has direct benefits down here, like things for bone loss. We have a very high-tech water purification system that we have developed, and that technology is transferred directly to Earth so people in rural places can get clean drinking water, the simplest of things.
Right. And the space station has been up there for many years, but what does the future hold for it?
The future is bright for the ISS. We're going to fly until 2028 or give or take. This station is going to serve as a platform for continued scientific research and technology development. We're going to use that technology as we segue into going to the moon with the Gateway project. The commercial crew program is being astronauts to the ISS on American rockets from American soil. So, very bright future, and things are looking up again for Kennedy Space Center.
Yeah, the International Space Station sounds like a very important place. Thank you for telling us all about it.
Thank you.
Did you ever want to be an astronaut? Maybe it was the cool spacesuits, or the idea of floating in microgravity. Whatever the reason, it takes dreamers, thinkers, and adventurers to push the boundaries of human space exploration. But no matter how far we explore beyond our world, the journey ultimately starts right here, in the imagination of our youth. It is so important to support STEM, science, technology, engineering, and mathematics, focused education curricula to foster that next generation of rocket scientists, physicists, chemists, and of course, astronauts. These core building blocks form the foundation of the incredible achievements of NASA. The astronaut training experience here at the Kennedy Space Center Visitor Complex works with some of these bright children who may one day be the people who walk across the gantry into a capsule on their way to Mars.
My favorite thing about space is how we know so much, but then there's so much we can learn about it because of how big and endless it is.
What I love about the ATX Center is the microgravity simulator. That was really fun because it felt like you were fixing the ISS in like zero gravity.
My favorite thing here at the visitor complex, if I had to choose, would be the shuttle launch simulator because it's so awesome to feel what the astronauts would feel like when they take off.
More than 60 years of innately curious and wildly ambitious space pioneers have led us to countless new discoveries and modern conveniences we enjoy today. Literally thousands of items can trace their roots back to NASA, from smoke detectors and memory foam mattresses to life-saving medical equipment. It's amazing how the work being done to take us thousands of miles into space is also making life better right here on Earth. Of all the benefits of modern technology, perhaps none are more powerful than our ability to connect with another person anywhere, instantly. To pick up a cell phone and call a loved one many thousands of miles away, to instantly share a photo with our network of friends, to collaborate and share information with like-minded people to create something great together. In a way, the modern communications technologies are making Earth feel like a smaller place. And while they are bringing us closer together, they are also enabling us to look further beyond our horizons. The journey starts here. By going behind the gates at Kennedy Space Center today, we each took our own small step toward the future of space exploration by learning and being inspired by the incredible achievements of NASA.
So the question, where does space begin? It depends on your point of view. You could really ask, where does the atmosphere end? And as you think of the atmosphere where we live and breathe here on Earth, it doesn't just stop right above our heads. It doesn't stop at Mount Everest. It doesn't stop where the planes are flying. It goes on and on all the way up and just gets less and less dense the higher you go. And it's still there at a very high altitudes when you go to where the space station is, only a couple hundred miles above the Earth. There's still enough air there to slow the space station down. And if you didn't reboost it with rockets, it would come back to Earth based on the air drag, just like when you're driving your car. So that region up there, even though it's not like what we're used to here, you couldn't breathe there, there's still enough atmosphere there to make it interesting. Not only is there air like we have on Earth, there's ionized gas, there's radiation. All those things together make the environment really dynamic and has something we call space weather. And in a sense, we live in the atmosphere of the sun. So there's this kind of dichotomy there where you go from the Earth's atmosphere, then you're in the sun's atmosphere, and then at some point you're outside that when you reach the heliopause and the heliosphere boundary. So if the question is, where does space begin? It depends on your point of view. If you want to know where does the atmosphere end, it's about 400 miles over your head. But just remember that that space above that is not empty. It's full of all kinds of interesting stuff. And that's what we study at NASA.
Why
can you see the moon during the day? We think of the moon as a nighttime object because it's often shown that way to us in books, movies. Even the weatherman uses the sun as a symbol for day and the moon for night. But the moon actually spends almost as much time in the daytime sky as the night. You just have to look a little harder to see it. Let's think about why we can see the moon at night at all. Unlike our sun, the moon doesn't create its own light. We can only see it because light from the sun is reflecting off of its surface. Same is true during the day. And unlike the stars, which are also still up there during the day, but we can't see them because the sky is too bright, the moon actually shines bright enough that you can see it day or night, as long as it's in the right part of the sky. During a full moon, the moon is opposite the sun in the sky. That's why we can see the full face of the moon reflecting sunlight. As the Earth rotates, the moon rises just as the sun sets, but just on that one day of the month. In the days before a full moon, if you look in the eastern sky, you can find the almost full moon rising before the sun sets. In the days after a full moon, you can look in the western sky and find the moon setting after the sun has come up. Over the last year, I've actually made a game of timing my daily bike ride to see if I can spot it in the daytime sky. But it will keep you on your toes. It sets about 50 minutes later each day as it marches through its phases. So keep your eyes peeled and keep looking up. Maybe you can spot it too.
Where do moons come from? Well, they actually can come from a lot of different places. Our moon, for example, we believe formed in a cataclysmic impact between the early Earth and a Mars-sized planet. In just a few moments, this impact would have melted the entire Earth into the lava world, sending thousands of tons of rocks and material into space. Some of these rocks would combine together and form small moonlets, and over time, thousands of years, the moonlets would come together and form our moon that we see today. On the other hand, the Galilean moons of Jupiter are thought to have formed from a giant disk of debris that Jupiter pulled in from the gas and dust that orbited the Sun in the early history of the solar system. The material in that disk would also form those same moonlets that eventually came together to make up the 4 largest moons of Jupiter: Io, Europa, Ganymede, and Callisto. For the last common way moons are thought to originate, we have to look at Neptune's largest moon, Triton. This moon has a very strange orbit, which led us to hypothesize that it was actually a dwarf planet in the Kuiper Belt, just like Pluto. One day it got too close to Neptune and was captured by Neptune's gravity. So where do moons come from? Well, we still have a lot of questions that are unanswered, but with the next generation of scientists and state-of-the-art missions, we hope to be able to answer the secrets of the origins of the moons in our solar system.
Yes, definitely. But on other worlds, these aren't called earthquakes, they're called moonquakes or Marsquakes if they're on the moon and Mars. We know that these exist because we actually sent seismometers to the moon and to Mars. And when we sent seismometers to these worlds, we actually found thousands of quakes underneath the surface. Even when we don't have seismometers on other planets, we can actually tell that some worlds have earthquakes or had earthquakes in the past because there are cracks in the surface. And so when we see cracked rocks or even cracked ice on places like Europa and Enceladus, we know for a fact that there were quakes there to generate those cracks.
All right, welcome back everybody. We made it back to the visitor complex. This will conclude the bus tour for today. So let me say mission accomplished. Congratulations to everyone. All right. Now if you look to your right there, you see the 2 white boosters with the fuel tank. That's where I'll be letting everyone out. That's the Space Shuttle Atlantis building. If you haven't checked it out, please do. It's beautiful in there. Also, please remain seated until the bus comes to a complete stop. When it does and you stand up, please watch your head. You don't want to hit your head on the ceiling. Make sure you have all your stuff with you. And finally, watch that last step when you step off the bus. It is the tallest. Have a great rest of the day, everyone.